So now we are going to learn a couple reactions that esters can do. 17.9, this section is called hydrolysis. I think I spelled that wrong. Hydrolysis of esters. And there are two reactions that we're going to learn, like I said. And the first one is hydrolysis. And the second one that we're going to learn, which I'll put later on, is called saponification. In the hydrolysis reaction, we have an ester reacting with water to make a carboxylic acid and alcohol. And if you're really clever, you might be saying, wait a minute, that's the opposite of what we just did. We just did a carboxylic acid plus alcohol makes an ester. Now we're doing ester makes a carboxylic acid and an alcohol. And that's accurate. We are undoing the reaction that you just learned. So let's start with the generic ester. I'm drawing a little tiny ester, but this could be an ester of any size. And remember, the characteristic of an ester is it has this carbon-oxygen double bond with an oxygen, and that oxygen has a carbon chain hanging off of it, not a hydrogen. This, we need to react the ester with water, so it's plus H2O, and there needs to be an acid catalyst. Like, it's literally the exact same reaction, only in reverse. So acid catalyst, I'm going to write H plus underneath the arrow. And we'll talk about some of the other ways that we could write the acid catalyst. And the product of this reaction is a carboxylic acid and an alcohol. And let's do some color coding here. So there is our carboxylic acid that we make right there, and the alcohol right there. And the water molecule, its hydrogen ends up right here, and the oxygen and other hydrogen end up over there. So that's kind of how this molecule, or how this reaction works. So instead of H plus, you could see H2SO4, or you could see H3O plus. You might see heat. It's not as likely to see heat for this reaction. Let's practice a couple. This time let's write H2SO4 under the arrow. Okay, so how are we going to approach this? Like, what will our strategy be? So I would recommend you start with the ester, and you start with the carbon-oxygen double bond and the carbon-oxygen single bond. Like, that's going to be your first place to start. And whatever is on the other side of the carbon-oxygen double bond, that's going to stay with the ester. So that's one portion of the molecule. The other portion, this right here, there's our other product. And we need to add something to each piece of the ester. We've broken the ester into two pieces. We need to add something to each piece. I'm going to circle the two pieces. One piece gets a hydrogen, and one piece gets an OH. just like that. Now let's pretend like you didn't know which piece got the hydrogen and which piece got the OH. So we're backing up. One piece gets the hydrogen, what if you went like this? And one piece gets the OH, like that. We don't have that. Don't do this oxygen thing. Like we don't make that molecule. No, 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 no. One piece gets the hydrogen, one piece gets the OH. Carboxylic acid, alcohol, perfect. Let's do one more. And I'm going to make things real tricky. I'm going to put H2O on top of the arrow. I'm going to put H plus under the arrow. Look at that. Instead of writing plus H2O, I put it on the arrow. So first, look at your ester. Find your carbon-oxygen double bond and the carbon-oxygen single bond. That's definitely going to stay together as one of the parts of this molecule. And everything that's attached to the other side of the carbon-oxygen double bond, that stays with it as well. And then the other piece, we have the carbon chain. There. We've got to add something here. We got to add something here. One piece gets a H, one piece gets an OH. And there we go. That's the hydrolysis of the ester.